A cosmic enigma defies odds and logic. China's Mars orbiter captures a rare glimpse of Three-Eye Atlas.
While NASA remains silent, China has just changed everything. Between October 1st and 4th, 2025, China's Tianwen-1 probe, orbiting Mars, captured images of Three-Eye Atlas, the interstellar visitor racing through our solar system. One image, taken on October 3rd from nearly 29 million kilometers away, stunned scientists. It revealed not just a glowing tail, but a sprawling coma, thousands of kilometers wide. What Tianwen-1 saw wasn't just another comet. It was a question written across the universe, and no one has an answer yet. The first glimpse, how Tianwen-1 caught the interstellar wanderer. When the China National Space Administration announced the detection, it sent ripples through the global astronomy community. Their Tianwen-1 probe, quietly orbiting Mars since 2021, wasn't built for deep space comet chasing. It was a planetary surveyor designed to study Martian dunes and polar ice. Yet, in early October 2025, it turned its high-resolution camera away from the red planet and toward an unknown traveler, Three-Eye Atlas, the third confirmed interstellar object ever detected. Capturing it wasn't simple. Three-Eye Atlas was dim, fast, and unpredictable. The probe's instruments were calibrated for bright surfaces, not faint light drifting against a star-filled backdrop. Every exposure had to be timed precisely, and engineers spent nights recalculating trajectories so the camera could track an object moving tens of kilometers per second. For 4 days, between October 1st and 4th, 2025, Tianwen-1 hunted the wanderer across the Martian sky. Then, on October 3rd, success came. From roughly 28.96 million kilometers away, HiRIC captured the clearest view ever of Three-Eye Atlas. The image showed a compact radiant nucleus surrounded by a coma stretching several thousand kilometers across. Even through the static and cosmic haze, something about the symmetry looked deliberate, almost sculpted. Scientists in Beijing called it a once-in-a-lifetime frame. To them, it wasn't just a comet, it was a living fragment of another solar system, frozen in motion, drifting past Mars like a messenger from time itself. The data stunned mission planners. No other spacecraft had ever photographed an interstellar object so closely from another planet's orbit. China had done what no other nation, not even NASA, had achieved. And the fact that these images arrived while NASA's own high-resolution files remained sealed only deepened the mystery. The camera that shouldn't have worked, HiRIC's impossible shot. HiRIC, short for high-resolution imaging camera, was never meant to see something like Three-Eye Atlas. It was engineered to photograph bright Martian terrain, mapping craters and dust storms, not to chase a fast-moving, dim interstellar object across the void. Yet somehow, in the first week of October 2025, it pulled off what astronomers now call an impossible shot. The challenge was physics itself. Three-Eye Atlas was racing past Mars at speeds exceeding 68 kilometers per second, a blur of frozen gas and rock from Tianwen-1's orbit. Even the slightest timing error could have left the comet invisible, a streak of nothing across blackness. The camera team knew this. They calculated and recalculated exposure time, adjusting for orbital drift, solar glare, and the comet's unpredictable brightness. HiRIC was pushed to its absolute limits. When the images returned, they were astonishing. Against a backdrop of distant stars, a faint, glowing figure appeared, sharp enough to reveal both the solid nucleus and the vast, hazy coma that surrounded it. The brightness gradient suggested the object was active, venting material in real time as it passed through the solar wind. What shouldn't have been possible was now undeniable. China's Mars probe had successfully captured the first clear interstellar image from another planet's orbit. Behind the scenes, engineers admitted something strange. The exposure pattern had to be shifted mid-capture because the object's movement wasn't matching the predicted paths. Three-Eye Atlas seemed to be drifting slightly off course, as though propelled by something beyond solar radiation or gas jets. It wasn't a huge change, only a fraction of a degree, but enough to raise questions about what was really guiding it. The moving shadow, China's GIF that shocked the world. A single still image would have been historic enough, but China didn't stop there. A few days after the Tianwen-1 announcement, the China National Space Administration, CNSA, released something that stunned the world. An animated GIF made from multiple high-res frames. It showed 3I Atlas moving slowly across a field of background stars, a faint blue-white light shifting almost imperceptibly with each frame. It was short, grainy, and silent, yet it carried more weight than any press release NASA had issued in months. That simple animation, a glowing dot gliding through the darkness, confirmed one thing: 3I Atlas was alive with motion, not a frozen relic drifting passively through space. The images revealed how the comet's coma shimmered as it rotated, its brightness fluctuating in subtle patterns. Astronomers analyzing the sequence noticed that the tail appeared to bend and pulse as if reacting to invisible forces. Some attributed this to solar wind interference. Others saw something more deliberate, a rhythm too structured to be random. Across social media, the clip went viral within hours. Space enthusiasts called it the blink of another world. Scientists marveled that Tianwen-1 had captured what even Hubble and Webb hadn't yet shown: the unmistakable living motion of an interstellar traveler. And while the world debated what it meant, NASA stayed quiet. Their high-rise data, collected at nearly the same time, still hadn't been released. That silence gave the GIF an eerie power. For the first time, the public was seeing something humanity couldn't fully explain: an object from another star system caught mid-flight, defying predictions. The faint flicker of 3I Atlas wasn't just light, it was information, whispering across the void, teasing a mystery no one was ready to solve. What China had released wasn't just an image, it was a message, and it made the rest of the world realize they might be looking at something far beyond science as we know it. The strange glow inside the coma of 3I/a TLAS. When Chinese scientists enhanced the images from Tianwen-1, they found something they hadn't expected. Around the solid core of 3I Atlas was a massive, shimmering cloud, the coma stretching thousands of kilometers across. But this wasn't the kind of glow astronomers were used to. It didn't diffuse gently into space the way a normal comet's tail does. It pulsed, as if lit from within. Every frame showed tiny fluctuations in brightness, too regular to be camera noise, too organized to dismiss as a coincidence. Normally, a comet's coma glows because sunlight heats its icy surface, releasing water vapor and dust. Yet the analysis of Tianwen-1's data showed that 3I Atlas's coma contained far less water than expected. The light signatures pointed to carbon dioxide dominating the mix, with trace elements of nickel and unknown metallic compounds. Those readings didn't fit any model of a natural comet. It was as if the object's chemistry was fine-tuned for resilience, built to survive radiation, heat, and pressure that would destroy ordinary material. The glow also behaved strangely when compared to known reflections. In one segment of the sequence, the inner halo brightened sharply, then faded again in perfect cycles, almost like a heartbeat. Some speculated this could be caused by rotation, but the rhythm didn't match the object's predicted spin rate. That meant the light was likely coming from localized emissions, not just reflected sunlight. NASA, still holding on to its unreleased high-rise images, offered no comment, but everyone knew that if those sharper US images existed, they could confirm or deny what Tianwen-1 had seen. Until then, the only clear evidence came from China, and that eerie, steady light coming from an object not meant to glow that way kept the mystery alive. The impossible distance, how China's probe captured it from 29 million kilometers away. At first, the numbers didn't seem real. The Tianwen-1 probe, orbiting Mars, had captured its now famous 3I Atlas images from nearly 28.96 million kilometers away, a distance so vast it defied logic for a camera not designed for deep space photography. To put that into perspective, that's about 75 times the distance between Earth and the Moon. At that range, even a tiny miscalculation in focus or trajectory could mean missing the target entirely. The high-res camera aboard Tianwen-1 wasn't meant for this kind of work. It was engineered for bright Martian terrain, rocks, dunes, and canyons, not for faint cosmic specks racing through the blackness. Yet, in early October 2025, the Chinese team repurposed it for one of the boldest imaging attempts in space exploration history. Using a series of manual corrections and long exposure sequences, they managed to lock onto 3I Atlas as it streaked through the solar system, traveling at tens of kilometers per second. What made it even more remarkable was the clarity of the data. Despite the enormous distance, the images showed not only the nucleus, but also the detailed coma structure, proof that the probe's stabilization and tracking system was operating with almost supernatural precision. Each pixel of that image represented millions of kilometers of space, and yet the details aligned perfectly. But what truly intrigued scientists was why Tianwen-1's team had aimed at 3I Atlas in the first place. China's space agency had quietly tracked it for months, long before it became public news. That meant they knew exactly when and where to look. Whether it was foresight, coincidence, or inside knowledge, one fact became clear. The clearest look humanity had ever gotten at an interstellar visitor came not from NASA, but from Beijing. And with that, the balance of discovery and secrecy had shifted. The silence from NASA. Why the US hasn't released its own images. As China's Tianwen-1 images spread across the internet, excitement turned to frustration in the West. For weeks, people kept asking the same question: where are NASA's images? After all, the United States had its own spacecraft, the Mars Reconnaissance Orbiter, equipped with the high-rise camera capable of 3 times the resolution of Tianwen-1's HiRIC. It had observed 3I Atlas around the same time, yet not a single photo had been released. Officially, NASA said the delay was due to the federal government shutdown that began just days before the comet's closest pass to Mars. According to the agency, non-essential operations, including data releases, were temporarily suspended. But that explanation didn't sit well with scientists or the public. A government shutdown could pause press briefings, yes, but not the transmission of raw space data. The Mars Reconnaissance Orbiter still had power, bandwidth, and instructions ready to send back information. As days turned to weeks, the silence grew suspicious. China had managed to capture, process, and publish its images within days, while the US, with better instruments and a larger team, remained quiet. Even members of Congress began to take notice. On October 31st, 2025, Representative Anna Paulina Luna sent a formal letter to NASA's acting administrator, demanding the immediate release of the 3I Atlas data and images. Her message was direct. The public had a right to see what their tax-funded satellites had captured. The longer the delay continued, the more China's achievement dominated headline. For the first time, it wasn't NASA leading a major space discovery. It was China shaping the narrative of an interstellar mystery. And that silence, intentional or not, only deepened the sense that something about 3I Atlas was far stranger than anyone was willing to admit. The political shockwave. Congress steps in. By early November 2025, the situation had escalated far beyond astronomy. What began as a scientific delay had now become a political storm in Washington. The release of China's 3I Atlas images, paired with NASA's silence, set off what some described as the first space transparency crisis in decades. It wasn't just scientists demanding answers anymore. It was lawmakers. On October 31st, 2025, U.S. Congresswoman Anna Paulina Luna, AFLA, sent an official letter to NASA's acting administrator, Sean Duffy, calling for the immediate public release of all data and images related to 3I Atlas. Her statement was clear and uncompromising. She accused the agency of withholding critical scientific information and questioned whether the delay was truly about a shutdown or if something far more deliberate was happening behind the scenes. The letter went viral overnight. News outlets framed it as a rare direct challenge to NASA's secrecy. For years, space policy had operated quietly under bipartisan respect, but now 3I Atlas had pushed that piece to the edge. Congressional aides confirmed that private briefings were held with NASA officials, and though the contents weren't made public, multiple insiders hinted that the agency was not comfortable with what the images contained. Meanwhile, China's Tianwen-1 team continued releasing snippets of their own findings, high-resolution stills, brightness readings, and even spectrographic data from the captured frames. Each new piece added fuel to the fire. The Chinese space agency looked confident, transparent, and prepared to lead the discussion on interstellar science. In contrast, NASA's silence felt defensive, almost fearful. The secret images, what NASA might be hiding. Behind the walls of NASA's Jet Propulsion Laboratory, a quiet tension grew. While the agency maintained that the delay was caused by the government shutdown, insiders whispered a different story, that the high-rise images of 3I Atlas were unlike anything ever captured. Multiple leaks suggested the images showed structures or patterns within the comet's coma that could not be explained by natural outgassing. These weren't just streaks of gas and dust. There were shapes, faint but distinct, as if the object's surface wasn't jagged or uneven like typical comets, but smooth and geometric. If true, that would mean 3I Atlas wasn't just an interstellar rock. It could be something constructed. That idea, once dismissed as science fiction, now seemed impossible to ignore. Even Harvard astrophysicist Dr. Avi Loeb, known for his study of Oumuamua, noted that 3I Atlas's behavior, its acceleration patterns, its unusual reflectivity, its controlled motion, all hinted at a form of intelligent design. NASA's silence suddenly made sense to some. The agency has always walked a fine line between scientific discovery and public reassurance. If the high-rise camera aboard the Mars Reconnaissance Orbiter truly captured an interstellar object behaving unnaturally, releasing those images without full analysis could spark global panic or misinterpretation. After all, space agencies rely on control, not speculation. And so, while the world watched China lead the narrative, NASA stayed silent, guarding the clearest, highest-resolution look at 3I Atlas ever taken. Whether that silence was caution, fear, or something deeper, no one outside those closed doors truly knew. But one thing was clear: whatever high-rise captured that week in October 2025 had shaken the agency to its core. China takes the lead. How the disclosure changed the global balance. For the first time in modern space history, China, not the United States, became the main source of data about an interstellar object. The release of Tianwen-1's images on October 5, 2025, just days after 3I Atlas's close pass to Mars, sent shockwaves through the global scientific community. The Chinese National Space Administration, CNSA, didn't just beat NASA to the punch. It redefined who held authority in the new era of space discovery. The Tianwen-1 probe, originally designed to study Mars, wasn't meant to photograph distant, dim, and fast-moving targets. Its high-rig camera was built for bright, planetary surfaces, not for deep space imaging. Yet, through a combination of precision engineering and quick adaptation, Chinese scientists managed to focus on a small moving point of light, traveling millions of kilometers away, and captured it. The feat was hailed as impossible imaging, something no other active probe had ever accomplished. The release data showed 3I Atlas glowing with a structured halo, a dense coma several thousand kilometers wide. Some frames even appeared to reveal faint internal reflections, unusual bright patches that changed position between exposures. Whether these were caused by ice crystals, reflective minerals, or something else entirely, CNSA left the interpretation open-ended, simply labeling them spectral anomalies. The global race for truth. What happens next? As the mystery surrounding 3I Atlas deepened, the world entered a new kind of space race, not for territory or technology, but for truth. China's bold move had shifted the balance, and now every major space agency was scrambling to analyze, respond, or regain control of the narrative. What was once a quiet scientific observation had become a full-scale geopolitical storm. Inside NASA, pressure was mounting. The high-rise images from the Mars Reconnaissance Orbiter remained classified. Stored behind multiple layers of internal review, officials cited the government shutdown as the cause for the delay, but that excuse was beginning to crumble. Congressional hearings were being discussed behind closed doors. Representative Anna Paulina Luna's letter had sparked an investigation into NASA's chain of communication, and now journalists were uncovering reports that data servers connected to the imaging division had gone into restricted access just hours after the Chinese release. Meanwhile, Europe's ESA, India's ISRO, and Japan's JAXA all issued formal statements requesting data-sharing transparency, calling the 3I Atlas event a scientific moment that belongs to all humanity. Yet beneath the diplomatic phrasing, there was urgency, the kind that comes when the unknown feels too close. China, for its part, doubled down. On November 10, 2025, the CNSA released a follow-up report describing faint blue spectral flashes detected near the comet's tail, short-lived bursts that didn't match any known outgassing pattern. These flashes coincided almost perfectly with the timing of Voyager 1's plasma detections at the outer boundary of the heliosphere. The implication was chilling. Something from deep space might have triggered simultaneous reactions across billions of kilometers. Whatever the truth, the world was no longer waiting. Every telescope, every probe, every radar system capable of scanning deep space was now locked on the same target, 3I Atlas. It had become the most watched object in the sky, a silent visitor carrying answers no one fully understood.